Section 3, we want to talk about aldoses. So the thing to remember is that you're going to have an aldehyde up at carbon 1, and then you're going to have a variety of hydroxyl groups in between before you say get down to the bottom one here. And the idea here is to recognize that we're always going to be talking about D sugars. So here is the fixed hydroxyl group to the right, that's the D sugar. But the other stereogenic centers could be in the R configuration, like as shown here, or in the L configuration, which I will now draw, okay? So both of these are in the D configuration because this hydroxyl group here is to the right. The arrow on the left is pointing to the R configuration here, and the arrow on the right is pointing to the S configuration here. So remember the idea that you can have 2 to the nth stereogenic centers. So if we have, in this case, we just have one stereogenic center, there's going to be a maximum possible stereoisomers of 2, okay? And I've drawn those. Here are the aldotetroses that I've just drawn. So this is D-erythrose and this is D-threose. Why is it D and D in both? Because the blue hydroxyl group is pointing to the right, okay? And those are diastereomers. They're not mirror images, they're diastereomers because only one stereogenic center is flipped, okay, with respect to the two. The lower stereogenic center is the same for both of them, okay? So these two are diastereomers, okay? Or we could say constitutional isomers. Here are the aldopentoses. As you can see, there are 1, 2 stereogenic centers. So 2 to the nth, where n is equal to 2, gives you 2 squared, which is going to be 2 times 2 or 4. So these are the 4 stereoisomers for the D sugars, okay? The 2 hydroxyl groups can both be to the right, both be to the left, or you could have one left, one right, or the other way. And these are called D-ribose, D-arabinose, D-xylose, and D-lysose, all right? If you're going into biochemistry, you're going to get your PhD in that and want to ace the MCATs or something like that, you might memorize these for your future classes. But this is not what we're doing in organic chemistry. All of these 4 are diastereomers. Here are the aldohexoses. Again, we have an aldehyde at carbon 1. It's called a hexose because you have 6 carbons, and ose is the ending of all of your sugars, okay? So these are called D-allose, D-altrose, D-glucose, which we're kind of familiar with, D-mannose, D-glucose, D-idose, D-galactose, and D-talose. These are all sugars that have the D configuration because the bottom hydroxyl group is to the right, but then the OHs on the remaining carbons in red could be all to the left, all to the right, and intermediates in between. How do you know how many there should be? How do you make sure you draw them all? You count the number of stereogenic centers that you're varying here, and the variety is going to lead to all of those. Okay, so 1, 2, 3, 4 is n is equal to 4. So we want to calculate 2 to the 4th power, which is equal to 2 times 2 times 2 times 2. I'll let you do the math there. Why are there 8 here? Oh, I miscounted. Let's rewind the video. So what we have here is n is equal to 3, and n is equal to 3. So your maximum number of stereoisomers is going to be 2 to the nth, which is 2 to the 3rd, which is 2 times 2 times 2, which is 8. And there's 8 on this slide here, okay? So those are the configurations there. All of these on the screen are diastereomers, okay? These are all diastereomers. All right, so that's it for this chapter section. Let's go to the next one.